Hi everyone and welcome to this talk. I'm Francesco Tisiot, developer advocate at Aiven. And today we together are going to understand how we can fix our strings. And I wanted to give you an example of why we should fix strings, and I didn't have to go that far. Because if you check, my name is Francesco Tisiot and has a unique property. This name is never understood anywhere in the world. Because if I'm staying in Italy, people usually don't understand my surname. They start calling me Tisio, Tisiotto, or Tisiot, or just Tizio, which is the Italian way of saying buddy. If I go outside of Italy, people usually don't understand my name, so they call me Francisco, Franciscos, or just Frank. This thing happens every day in my life. What are all those things that we see on the screen? All of them are strings. And strings are beautiful because in strings we can store pretty much anything that we want. For example, we can store names like Francesco. We can store entire sentences like I come from Verona, I like football and good food. But we can also misuse strings. And we, for example, could store potentially full images. Because if you check what's behind that image there, well, there is a string. We can store lists of things. And then here we go into the devil part of the talk. Think about this number, $1,200. Do you think it's a number? But this is not a number. I've never seen a number with a dollar sign at the end of it. This is a string, right? And the same goes for a date, 25th January 2021. You can store that as a string. Now, you think I'm joking, but actually in my career, I saw pretty much all this kind of data stored as strings. So I wanted to give you an example, as I said before, and I took the example with my favorite restaurant, receiving calls and receiving bookings for the meal, the dinner, or the lunch. And in my case, I'm calling and telling them that I want a table for two, and they always don't understand my name and say, okay, Francisco, let's book a table for two. Now, I thought about my favorite restaurant, going away from writing down in the book all the bookings, and using, of course, Postgres in order to store the data. So they create a table called My Restaurant Data, where they write, first of all, the ID of the booking, the name of the person calling in order to do the booking, together with the surname, all text, all varchar. Then they want also to store the email of the person because they want to send some marketing emails, and the phone number. The phone number usually are only numbers, but sometimes I want to add the plus 39 in the case of Italy. It's the country codes. Sometimes I want to add a space or a dash. I give this possibility to the person writing down the record because I want to minimize the time that it takes for one employee to take up the phone and write down the record itself. Then I do pretty much the same for booking date. I can write dates in different formats in Europe and in the US. I know we have different opinion about dates. So in order to simplify the inserting of the data, I just store that as a varchar. Then something more. For example, my favorite restaurant is really fancy, so wants to give a detailed experience to every person going into the restaurant. So it stores the list of interests of a particular person. And also, of course, if you do a booking, the number of people. But since the number of people can be defined in several ways, for example, I could say I'm coming with 5 people or with 4 adults and 1 children, again, I'm storing that as a varchar. Now, my favorite restaurant implements this table, start collecting orders, and booking, and everything works because they can insert every time all the information required. But at a certain point, they try to check out the data in the table. And they probably will say something like this. And this is just filtering of my bookings. In here, we have all the columns that we defined with all the values, all the strings that we defined. And we can see clearly some of the problems. For example, in the caller name and caller surname, we see that there is a lot of weird symbols on top of our characters. We see that the names are not really written in a good way, and we should fix that. The same goes for the email, where we see a mix of personal email, work email. The third row, that's not an email because it has a $sign in it. Let's move to the phone number. Again, this is more or less a mix of more or less the same number, but with different formats. And the last row, well, that's not a phone number, it's a date. And if we check the date, those are almost all valid dates apart from the last row, which has the phone number. So they switch the columns. If we check the dates more in detail, we see that there is some potential valid date. Check the second row. Is that the 10th of May of 2021, or is it the 5th of October? We will never be able to know. Also, check the second to last row, 31st of November 2021. That date, at least in my calendar, doesn't exist, but still we are allowing that to be inserted. Let's move to interest. If we give people the option to define their own delimiter for a certain field, they will use whatever they like. They will use commas, semicolons, dashes, or nothing. Check the second to last row. Is that football Pinot Noir and Tagliatelle, or football Pinot and Noir Tagliatelle? We will never know what's the reality there. Last, people. Again, we have complete freedom, so we don't know if the 4+1 is for adults and one kid, or the opposite. We don't know if the reservation for 55 is 5+5, or really a reservation for just 55 people. So we want to fix that. This is not acceptable anymore. How can we fix? Well, first of all, we want to understand all the different rows having this kind of Francesco Tisiot variations, and we want to create the unique Francesco Tisiot record. Well, that seems sensible. In order to do that, we need to define and find a unique identifier in our data. That if you use, like in our case, an email, or even if you create a web entry in order to record user details, the email is usually a good column to define uniqueness, because it's in ASCII code and it's really parsable. But the email is not perfect, because people could use different accounts in order to make a booking or to create a profile. They could use work and personal account. They could use group accounts. For example, if I want to go out and have a dinner with my marketing department, I will use the group account in order to do the booking. Even more, depending on your provider, email can allow symbols or not. For example, if you use Gmail, tomhanks@gmail.com is the same email as tom+hanks@gmail.com. But other providers works differently. So it's always hard to match emails. Even more, if an email is left, it can be reassigned. So for example, if in 10, 20 years, another Francesco Tisiot will join Aiven, he will probably start receiving all the lovely emails that you already submitted me. So thank you. So, we can do that. We can work with the email, but that's only going to solve some of the problems. On the other side, we can also understand that the entropy in a system never decreases. But what we can do now, we can change the structure of our table in order to avoid the entropy to increase a lot. We need to avoid the future chaos by fixing the problem now. And I believe we have done enough with slides. So now I will share with you a nice demo. Let's check it out. Okay, we are in a demo. I'm connected to a Postgres database that is hosted in Aiven. And I created in the Postgres database the same table with the same rows that we saw before on slides. Now, let's try to start solving this issue about having strings everywhere, starting with the last column, the people one. So let's check what we have in the people column. So we have a lot of data. We have 5 rows with 5 plus 1, 4 adults and 1 kid, 1 plus 4. Is that 1 adult and 4 kids, or the opposite? We don't know. My suggestion here is, if you have a column or a set of columns for which you want to compute calculation which is not count or count distinct, you need to have that column in a numerical value, because otherwise you will not be able to do any calculation. So if we know, for example, that people when calling will also always specify a number of adults and a number of kids, we can create fields with integers. Like in this case, number of adults is an integer, number of babies is an integer. Then if we know that people will frequently request a table next to the window, we can add that. And then we can always leave a string as comment in order for people to add comments that we can periodically review in order to understand if we need to add other columns. For example, we may add in the future a column for vegetarian and vegan people if needed. So let's now try to insert kind of the same values as before. And let's check the table. What we see here is that the original value of 5, it was still for 5 people, and they wanted to sit next to a window. 4 plus 1 was 4 adults and 1 kid, and they want to look at the mountains. 1 plus 4, well, it was actually 1 adult and 4 kids, and the comment helped us understanding that it was a correct booking because this person needs some help with 4 kids. The 55, well, actually, it was only 5 adults and 5 kids, and it's probably a birthday. Now that we have this information as numerical, as integer, we can also add additional checks. So, for example, if someone tried to book for more than 10 people, we could ask, for example, an additional question, the credit card details to reserve the booking, because they are occupying quite a lot of space in the restaurant. So I can say that we solved the problem for the people. Let's move to another column. Let's now move to the interest column. If we browse what we had with the interest, it was custom selection of the divisor, basically the strings between the various options. This is a problem because, we cannot parse this data anymore. But with Postgres, you have an option where you can still allow to specify just the unique strings, and you use the array to store the different strings together. The array allows you to store multiple values within kind of the same row, the same cell in your table. In this case, I'm storing Pinot Noir and Tagliatelle within the same column. So this is beautiful, allow us to insert more values within a unique column. The beauty of using arrays is that once you store the data as an array, you can use the array function to play with it. For example, we can unnest and create from the array having 2 values, the 2 rows, Pinot Noir and Tagliatelle. Or we can do also advanced functions like, for example, if I know that 2 persons have interest, I want to know if they have common interest. So I can use the intersection here to check if, for example, the first person has Pinot Noir and Tagliatelle as interest, the second has Riesling and Tagliatelle. So they have Tagliatelle as intersection. In the second case, there is nothing that the 2 people have in common. So I can use the power of the array function in order to check these interesting bits. Let's now move to the booking date. As we saw here, we have a complete chaos. There are dates for which we are not sure about it. There is a phone number, there is a non-existing date. The suggestion here is every time you have a date, store it as a date. And you may say, well, if you store stuff as a date, you lose the ability of displaying the date or writing the date as you wish. For example, if I have to build an app that is going to be used by American and European, they may want to select and write the date in different formats. But even if you store stuff as a date, you don't lose any flexibility, because as long as you pass the correct conversion string, you will always be able to write that as a correct date. And if you store that as a correct date, then you can select when you take the date in as output, how you want to display it, so you don't lose any formatting option. Even more, if we use a date to store a date, what happens if we try to insert a phone number? Well, we will have an error. What happens if we try to insert the 31st of November, which doesn't exist? It will tell us, look, that this date doesn't exist. So it will prevent us from making mistakes. So can we also close the date bit? Let's pass to the phone number. Now, the phone number here, it's a mix of a lot of things more or less talking about the same phone number in different formats. And I'm taking the phone numbers as example of a column where you may want to require a certain format. For example, in Italy, we usually write the phone numbers as something like this, as plus, then two numbers, then we write something, dash, something, dash, something. This is the typical way of writing down numbers in Italy. So I can use the like function to check the existing values, within the existing values, which one follow the pattern that I defined. And I can see that the like function takes out the bottom three and allows the top three, which, it's quite cool because they follow the pattern. But if we look closely at the second row, this is an A. This is not a valid number. We want to check that we are inserting digits in the format. So the like option is not enough, but we can use regular expressions. With regular expression, we can define much more in detail what we expect on that column. So we expect plus, then between 2 and 3 numbers, then a space, then 3 numbers, a dash, 3 numbers, a dash, another 3 numbers, and then the end of the string. If we now check with the regular expression, it filters out all the 4 bad combinations, allowing only the top combination. So how we can take this regular expression into use? We can create a domain called phone number. And the domain, what does, it checks that the value follows our regular expression. Now that we created the domain, we can create a table with a column using the domain. In this case, I have a column called p number, which is of domain phone number. And now if I try to insert the valid row will go through. If I try to insert all the other rows will violate the check constraint. So they will not be able to be inserted. Only one row will go in. Only the valid row will go in. I copied the row twice, so I get the row twice in my dataset. We can do the same for the email. We can create email. We can create an email, and we can write the regular expression. Now, you would think that I was so smart of defining this regular expression for the email, but I took that from Stack Overflow, and I will give you the link later on in the session. So I created the domain also for the email. Now, let's tackle the last part, the name and surname. What we have here is a lot of misunderstanding, probably a little bit of fat fingering because we have a lot of accents. So the first thing that we want to do is remove those accents because in Italian, at least, they don't make sense. For this, we can use the unaccent extension that, as the word says, pretty much removes the accent. One key thing here, different languages, for example, Italian and German, have different way of removing the accents depending on the word that has the accent. So you may want to localize the unaccent with your language. But as we can see, for Italian, it does a pretty good job removing all the accent that I have in my initial value into the second column. Now that I remove that, still I have different variations of Francesco Tisiot. So I can use the extension called fuzzystrmatch, Within the fuzzystrmatch extension, I have a couple of interesting functions. The first one being the Levenshtein difference. The Levenshtein difference calculates the number of different chars between two strings. So if the two strings are equal, the Levenshtein difference is 0. Otherwise, it's 1, 2, or 3, depending on how many characters are different. In this case, E and I. In the second case, SE and SI. So you get how this works. Now, whenever we receive a call by someone that wants to do a booking in our restaurant, what we could do is use the Levenshtein difference to check if we have in our database someone that sounds like the caller. So if we write a query, we can, for example, let me show this, say that the caller is, we understood that the caller is Francesco Tisiot, but we have in our database someone called Francesco Tiziotti that if we remove all the accent and we apply the Levenshtein difference, the Levenshtein difference is only 1. So it could be a good match of the string of the caller that we understood by the phone. Still, the Levenshtein difference has the problem of being related to what we write. And you know, different people in different language might understand and write stuff differently. So we would like also to have the possibility of, for example, checking the sound of a word based on what we write. And we can use for that the soundex function, always belonging to the fuzzystrmatch extension, that basically associates the English sound to a word. It works only with English. I hope it will be extended to other languages, but still it's very useful. And what this is doing is saying that Tisiot and Tisiotto, they sound pretty much exactly the same because they have the same sound code. While Tisiot and Tisioppo, they sound a little bit different. So this gives the soundex function give us the sound based on the string, but there is also another function called soundex difference, or basically difference, which despite what the function name is, doesn't show us the difference. It shows us a soundex value. In this case, let's see, the first row, Tisiot and Tisiot, they sound pretty much the same, so they have the maximum score, the maximum soundex score of 4. Tisiot and Tisiot, they sound a little bit different, so the score is not 4 anymore, it's 3. The soundex score goes always from 0 to 4. 0, two strings don't sound the same. 4, they sound exactly the same. So, you know, we have now all the tools that we need to fix our strings, to fix our restaurant table. So let's do that. The first thing that we want to do is to divide the person, the client calling from the booking itself, because we don't want to repeat the client information for every booking that the client is doing. So we will create a separate table for the client, including an ID, the name of the client, the surname of the client, the email, which is an email domain now, the phone number is a phone number domain, and the interest is an array of varchar, not just a varchar anymore. Now we can also create another table called My Restaurant Booking, which has the same ID, the My Client ID, which is a foreign key pointing to my restaurant client. Then it has the booking date, which is now a date, the number of adults and children, which are integer, and the comments that we leave there in order to understand if we need to add other columns in the future. What we can do is also adding helper functions that allow us, if I hear a name when people call my restaurant, to find which are other rows in our client table having a similar name, using the Levenshtein and the soundex difference. And I can do that as well for the surname and the email. Now that I have all the building blocks, let's try to insert some data. Let's say that my restaurant takes the new tables into usage and they have some clients calling them. We have 4 clients, myself, Ugo Rossi, Uga Bianchi, and Francesca Verdi, with email, phone number, and interest, all working as expected. Now, let's say that someone calls and says, my name is Ugo. I want to use the helper function, similar name, and I can see that I have two rows, Ugo and Uga, which have a Levenstein difference and a Sandex score, which are close to the Ugo that I listen. So I can ask a follow-up question, what is your surname, to identify if the caller is already in my list of clients or not. The same goes if I listen that someone says, my surname is Tisiotto. Well, there is Francesco Tisiot, which is similar enough. Or for the email, ugorossi@email.com. Well, we have a ugorossi@email.com without the dot, so maybe you are the same person. Let's try now to insert in my client table something which has a field which should be an email, but is not an email. Well, that violates the constraint that we create on the email before. Now, the beauty of also having the interest as an array is that, as I said before, I can use the array function. So, for example, I'm creating a night based on the Pinot Noir. Who should I invite? Well, I can get that information from the table itself. Or I don't have any imagination. I want to create a night which will be as much successful as possible. I can change the shape of the pivot table to tell me that, look, that if you want to create a night which grabs the attention of most of the people, you should create a night about spaghetti, because you have three people, Francesca, Francesco, and Ugo, that are interested in that. So, all this kind of operation are available only because we were using arrays. Now, let's try to make a booking. I want to make a booking. For myself, I'm number 1. For the 23rd of November 2021, 4 adults and 1 kid. I want to sitting near the window staring at Verona's arena. It's amazing, and the booking goes through. Let's try to do another booking, always for myself, always the same date. This time 1 adult and 4 kids, because I did a mistake before. Let's try to do this. Well, since now we have the client and the date, the client information in another table and the date in the booking table, we can also, in this case, create a constraint that we allow only 1 booking per person per day, something that we couldn't have before. I can always update my previous booking if needed, and that goes through. Now, let's try the last operation. I'm the devil person that wants to try to do a booking for the 31st of November. Since now this is a date, it will tell me, look, that the 31st of November is out of date range. So with fixing all the column values, we now have a more stable table definition that allow us to insert the data in the same way as before, but avoid all the errors. Now, let me go back to the slide to finish off my talk. So what we did now is, when we went from chaos to order, we fix all the column values with proper handling of the data types and with proper helper function that help us understanding if we have similar strings or not. I want just to conclude by giving you all the references that we have been talking about today. So array functions, date functions, pattern matching, useful if you want to understand if a string is more or less similar to another. Domain, to use those kind of regular expression in order to check the value of a certain column. The email domain, this is a short link to a Stack Overflow post where you can find all the details of the string that I used previously. The unaccent extension, together with the fuzzystrmatch extension, which contains the Levenstein and the Sandex functions. And lastly, Aiven.io, the company that I work for. We offer Postgres as a managed service, so please come and check us out. I hope you enjoyed a little bit my talk about Postgres, strings, and football. I hope to see you soon, and you can reach always me out if you have any queries. Thank you very much, and hopefully see you soon. Bye-bye.